Welcome, I'm Maren Ileman from KO Leuven, and today I want to show you a study we've been doing on cross-border balancing capacity coordination, and particularly we were using the open source modeling framework SpineOpt and the data management system SpineToolbox. First, I'd like to talk about the case study itself. What are different levels of coordination? Well, first, one could think of the activation of balancing energy, the coordinated procurement of balancing capacity, and the coordinated sizing of balancing capacity. And the coordination of these latter two was the particular focus in our case study. So what we call the coordinated exchange and the coordinated sharing of balancing capacity. The scope of our case study was a 2030 scenario for Central Western Europe with 5 countries. And we were focusing on the day-ahead market, considering a joint energy and balancing market clearing. Down below, you see a snapshot from the SpineToolbox project that I was using to do this study. The realization in SpineOpt, we do have the requirement that we need a high level of technical detail. So we were using a clustered unit commitment formulation, and we incorporated ramping and reserve constraints. Moreover, we were using a rolling horizon optimization, and we realized these different market scenarios through SpineOpt's generic constraints and just data-driven, differentiated between these different market designs. And on the right-hand side is a screenshot from the SpineToolbox data store. Results of our case study, and first of all at the exchange of balancing capacity, we do see that the must-run constraints are relaxed and that we're having a more efficient day-ahead scheduling. So lower flexibility, low OPEX units can operate closer to maximum output, and we avoid unnecessary startups. And that can also be observed in these right-hand side graphs. So on the upper left-hand side, we see the no exchange case where CCGTs need to be started up to provide AFRR, which is not the case for the exchange case. And in turn, in the electricity production in France, as it is here depicted, we can get rid of the startup of these CCGT units. This results in moderate cost savings of about 25 million euros per year. For the sharing of balancing capacity, we are benefiting for the joint sizing exercise and hence reduce the balancing capacity needs and can further relax our technical constraints. And this allows us to be even closer to an optimal day-ahead electricity schedule. This is illustrated to the right-hand side. If we look at the yearly average MFRR contracting, that's significantly lower, and this also results in a portfolio deviation for the electricity between the shared and the no coordination case, where we see that the CCGT, the OCGT, and the loss of load, so the expensive units, are significantly reduced compared to the no exchange case. And this results in moderate cost savings of about 155 million euros. But the question is this actually the biggest benefit, or is the bigger question, could the total amount of high flexible capacity be reduced? And the load duration curves for the CCGTs and OCGTs given below, we can clearly see that the load duration curves decrease. Thank you very much for listening.